Jupiter is the biggest planet in our solar system, and it has a rather big storm. The Great Red Spot is an enormous vortex that has been swirling for centuries. It's larger than our planet, but we don't know much about it. Although scientists have been able to observe the spot from outside until now, a NASA spacecraft launched 10 years ago has allowed us to finally get a closer look into Jupiter's weather. In today's episode, we are going to talk about the Great Red Spot on Jupiter. It is a fascinating yet terrifying discovery of this planet and is already known for its very large size and intense storms. The Great Red Storm of Mars has a lot in common with a storm on Earth. Its strength and danger are greater, but their importance is the same, determining humanity's future. Because it's basically made of clouds and could be considered similar to the types of things we know on Earth as cyclones or hurricanes or typhoons. Paul, a planetary scientist at Washington University in St. Louis, said this at 10,000 miles across distance. The Great Red Spot is the largest storm in our solar unit and has been continuously observed for around 2,000 years. But it's been around for much longer compared with that big storm on Earth, which generally lasts a few days or weeks at most. One might question how it lasts that long. Well, it's still a mystery. Before Juno, scientists had a hard time observing storms up close. From afar, they could tell the storm was changing shape and size, going from something they just noticed to something they knew inside a few hours. NASA launched the Juno mission from Cape Canaveral in Florida back in 2011 and arrived at Jupiter in 2016. The spacecraft changed course slightly and made a long journey to Jupiter, taking 5 years to complete. Bolton and his team used microwave sensors positioned in the depths of the storm to get a 3D model of the Great Red Spot. It's pancake-shaped because it's so wide at the top. The interesting thing here is that these storms that scientists were looking at on Jupiter, or vortices as they're called, apparently go much deeper than scientists would have imagined. Vortices are basically what we see on Jupiter's dayside, but they go below the clouds. In the case of the Great Red Spot, it extends at least 200 miles into Jupiter's clouds and is deeper than where clouds form. That's very different than the way we think Earth's atmosphere works, and it's largely driven by water clouds. Condensation in sunlight will require new models and ideas to explain what happens next. Juno's previous pass over the Great Red Spot took it at a blistering 130,000 miles per hour. On January 13, 2019, not enough passes have been made to fully measure an object as large as Jupiter. The storm caused the spacecraft to shake during its passage, meaning that observations could not be made without such a maneuver. Gravity in the local area tends to affect how Juno moves inside of the vortex. These bumps are why it's so hard for Marsiapirates to spot anything from the outside of their ship. A Juno scientist from NASA's Jet Propulsion Laboratory in Southern California. Scientists here on Earth could see the effects of these gravitational bumps. That's because every time they jostle Juno, the spacecraft gets closer or farther from the Earth. The radio waves sent back to Earth by the Voyager spacecraft 500,000 miles away have been subtly squeezed and stretched over time, as a phenomenon known as the Doppler shift. By using this effect, the spacecraft could detect tiny jostles as small as 0.01 millimeters per second, which is required to see if the Great Red Spots will get circled during the July 2019 flyby. Precision is required for such an important event, so it's impressive. The findings from the gravity's observations complemented Bolton's earlier microwave measures, concluding that Jupiter's atmosphere is 200 miles deep. Paris and his team had also discovered that the high-velocity jet streams responsible for Jupiter's iconic bands and zones extend from the clouds down to a depth of about 3,000 km. The new data collected by Juno's microwave instruments revealed that the jet streams are part of a larger circulation system similar to Earth's atmospheric cells. All Earth has its ferrule cells, which are located in each hemisphere and are an important factor in the Earth's climate. The team was founded by Pierce Caspi on Jupiter, which is 11 times larger than Earth with 16 ferrule cells. This is the first clear evidence of large methane snowbanks on Jupiter's atmosphere, providing a window into how the planet changes with temperature and atmospheric pressure. Observations of the Great Red Spot show that it's shrinking. For nearly a century and a half, the iconic spot has been getting smaller, and it's unclear just how long it will last before we see its demise. Juno has been observing the ingredients of storm systems as they're developing and stretching further and further in both its narrow view as well as a wider view. This is providing humanity with valuable insight into how these systems work and what changes we can make to avoid their worst effects. The storm appears to be trapped by powerful winds on the planet, which makes it easier to stabilize. Scientists predict the Great Red Spot will continue to shrink, but what's more troubling is that scientists are predicting that it could disappear altogether soon. Paul says that the storm event's current happenings allow scientists to do much more sophisticated modeling. They can simulate a much more accurate forecast. We can also make predictions for the future, including possible scenarios for when the Great Red Spot goes away. Floating polar hurricanes will likely emerge as a result of temperature changes on Jupiter. 5 years ago, scientists used data taken by Juno to learn more about Jupiter's poles. They found that Jupiter has 5 cyclonic storms at the South Pole, which is in the form of a pentagon. After Juno observed the cyclones 5 years later, using the Jovian infrared mapper, they found that they stayed in the same location. The polar cyclones were able to shift from the equator to their respective poles, with the stronger ones on top of their volcanic axis. The Juno spacecraft was used to find out why storms are staying in the same place on Jupiter, like Saturn. The findings from the mission are shedding light on how planets form and make discoveries in their early stages. Uranus, Neptune, and even planets beyond our solar system are all familiar to humans, as they have been moving through the celestial sphere since ancient times. This is the first time we've been able to open up and look inside a planet. This will help astronomers learn about the size of various planets in this galaxy. Today we have discovered over 1,000 exoplanets, or planets, that orbit a star other than our Sun. Terrestrial planets are too far away, making it difficult to observe what's happening on the surface. There's a 10.5 light-year distant planet that we can't even reach. Nearly 1,400 exoplanets have so far been discovered in a class of stars called gas giants, much like Jupiter. Jupiter, one of the largest planets in our solar system, reveals much about what life is like outside of Earth. Understanding its globe and how it interacts with other bodies in the solar system can help scientists learn more about how the universe works.